The thing about particulate matter is that it's ubiquitous. There's really no way to hide. And while it is a public menace, the policy approach has almost been hands-off private mitigation of exposure. Households are kind of left on their own to purchase air filters if they can. Private mitigation measures, that's obviously inequitable.
Welcome to VoxDevTalks. My name is Tim Phillips. I'm not going to surprise you if I say that poor air quality is a danger to our health, and of course, it's a danger to the health of young children in particular. But so far, most of what we know about this is from wealthy countries or from large cities in the developing world because, well, that's where we got the data. A multidisciplinary study that we're going to be talking about today estimates the impact of air quality on a much larger, poorer region. Policymakers, listen right to the end because there are really some extraordinarily surprising policy implications from this. Jennifer Burney of the University of California, San Diego is one of the researchers. So Jen, welcome to VoxDevTalks.
Thank you, Tim. Nice to be here.
We know, as I said, that poor air quality has large health effects in polluted cities. So what does the research that we've got from these locations tell us about the impact of the population of those places?
Yeah, it's really been something that's felt like an iceberg over the past, say, 2 or 3 decades of research, where every time researchers look for whether there's an association between exposure to air pollution and specifically really particulate matter, these suspended aerosols or particles in the air.
Tell me about particulate matter. What is it?
Particulate matter, sometimes called by its abbreviation or PM, refers to a class of pollutants that are suspended little particles in the air. And the smaller they are, the more dangerous they are for human health. The smaller they are, the deeper they go into our lungs when we breathe, and they can embed in our vasculature, and even the tiniest little particles can cross the blood-brain barrier and settle in on your brain. So they really have a capacity to infiltrate our critical systems. And really everywhere over the past few decades that researchers have looked, is there an association between higher exposures to particulate matter and some adverse health outcome? The answer has just been yes. It's just been more and more. So it's many decades that we know now that it's associated with things like visits to the hospital and premature death. But even in recent years, learning things like it affects worker productivity and educational attainment. Children in school do worse on tests, and even recent studies showing associations with things like dementia. So it's really not good in any dimension.
You freaked me out a little bit about this already, but there is a particular relationship between the amount of this matter that's in the air and child health, isn't there?
There is. Babies in their first year of life are sensitive. And they're also, in some ways, the street lamp in science, right? In that we sort of know where they are. We know what they're doing, mostly in and around their homes. And so it's a little easier to tease apart these effects, whereas adults are all over the place. They've had a cumulative set of experiences that condition their health, and it's a little harder to tease apart the impacts.
Why do we have better data about cities? We did an episode last year looking at data from Mexico City, for example. Why do we know so much more about cities than we do about larger regions?
I think it's honestly quite sensible from a historical and measurement perspective. Research quality and policy quality air monitoring stations are pretty expensive. And so typically the strategy has been more or less to place them in the most populated areas. So you're getting an understanding of the conditions relevant to the greatest fraction of your population, whether you're a county or a country, that's typically been the strategy.
Now, I note that there is some more recent research that has been analysing longer period variations and their effects on health using particles from natural sources. I would imagine it's very hard, but is it possible to establish some sort of causal relationship from something like this on something like health?
Yeah, you point to this tricky methodological point in all of this, which is We're always trying to move from associations where two things appear to move in sync. So more exposure, more bad outcomes, for example, moving from just sort of that association to a real causal story. Like it's the increased exposure that is actually causing the adverse outcome that we care about. And what's tricky in larger scale studies and in longer exposure periods is that there's all sorts of intervening factors that might not be accounted for, but might make that relationship look like it exists. So I think the big one that folks worry about is economic development or levels of income. We know that in countless ways, your access to resources conditions your health outcomes, right? So if you have access to healthcare, you're more likely to not have these cumulative health insults that pile up over time. So that's kind of a longer run story. But even looking across different places at one moment in time, you do worry perhaps that income might be affecting the relationship that you see. Specifically when it comes to pollution, especially in lower and middle income areas, increased incomes are associated with more pollution, right? People getting access to power, access to transportation, more industry. So these pollutant sources that tend to go with economic development might be confounding this relationship. So that's what makes it tricky.
I see. And that would cause us to underestimate the health impact of this, wouldn't it?
That's right. For example, in a place that's more developed, you've got an association that you measure between pollution and some outcome like infant mortality. And baked into that is those differences in levels of income that are actually having the opposite effect, right? Sort of bringing the mortality down. So you're adding a big negative effect and a smaller mitigating effect together, and therefore underestimating probably the true impact of pollution.
So Jen, in your research, you have looked at a source of dust particles. It's the Burney depression. I don't know about this. Tell me, what is it? Where is it?
So the depression is in the Sahara in current Chad area, and it's one of many natural dust source emission regions in the world, meaning that regular circulation and wind patterns are picking up big amounts of fine particulate dust and transporting it over thousands of kilometers. So there was recently news in the southern US that one of these Saharan plumes was reaching the southern US. So it really can go quite far.
I remember a few years ago, the sky over London was orange, and this was Saharan dust. So the dust is picked up and it's transported, and then everywhere that it goes, people are breathing it in.
Yeah, eventually these particulates settle out. They typically have atmospheric lifetimes of days to 2 weeks. And so wherever they go in that time, if they're sort of picked up by a stronger circulation pattern, they can go quite far afield. And then, as they settle down, you're breathing them.
So your research is looking at the impact on child health of this dust. First of all, there's data collection. You've got a huge amount of data to collect on where this dust is and how much of it there is. And secondly, on child health over time. Where do you get this data?
Great question. And this is where I'll give a very well-deserved shout out to the group of people I am privileged to work with on this, because that's what makes interdisciplinary work fun, is that you really get to push the envelope in all these ways. So let me just first talk about health data or outcomes data. One thing that's tricky is no deaths are coded as air pollution deaths. I guess in the UK, there was the first example of something actually being attributed in the past few years.
Yes, but that is one now.
One.
Yes.
Right. Typically, it's attributed to the underlying physical, most proximate thing, and so there's no way to just pull these data up. You've got to really look at birth and death records to understand expected mortality patterns and how much deviations from those patterns can be explained by other factors. And in this case, our team used records from the demographic and health surveys. So this is a set of coordinated surveys that take place across mostly developing economies, developing countries. And it's a big international effort to get harmonized data that is both representative nationally so that countries can use these data for their own policymaking objectives, but also comparable between countries so that we can, use a survey from Niger and use a survey from Kenya and use a survey from Bangladesh and put them all together to understand larger scale issues. So we used the set of surveys available from almost 2 decades across Sub-Saharan Africa. And these are household surveys. It's everything about what's going on with the household. And the neat thing is that there's a household record in there, who all lives here, along with questions about a mother in a household, like how many children have you had? Are they still alive? And from that, you can back construct a record of all the babies in this sample that have been born and whether they survive to their first year.
And what about the dust? How do you work out the exposure to this dust?
That's a great question, too, because as we started off with, these are expensive. There aren't very many monitoring stations, even really in most of the world, but especially on the African continent. And what's been really fantastic in recent years is the explosion of satellite observations of Earth's surface and the atmosphere. So we used a combination of 2 things. One is a set of derived measures of surface particulate matter from a group that's now at Washington University in St. Louis. They put together this ability to translate atmospheric observations into surface observations. And then the other thing was a product of just pure dust concentration and dust plume observations that was built by one of the authors on the paper, Kara Voss, as part of her PhD and postdoc work. So putting those 2 together gave us a sense of what concentrations look like in any given year. And then the dust data allowed us to understand when we were getting variations in pollutions really due from these sources further afield.
But that still leaves us with a problem, doesn't it, Jen, that you've got to establish some kind of causal link here. How do you get to that?
Yeah, so we used dust emissions from the Baudelaire Depression, this dust source area, as a way to think about whether across, especially West Africa, but really the continent, you were getting more or less dust than expected in a given year, or more or less particulate matter pollution in a given year. So in years when dust emissions from the region were higher, you see that unexpected component is associated with more mortality in these regions. We also looked at years when rainfall doesn't get much, but a little bit makes a big difference in a dusty area, when rainfall actually suppressed that dust emission and you ended up with, in fact, less dust than expected. And we saw that also mortality dropped in the same manner across the continent.
We are looking specifically at Sub-Saharan Africa for your data here.
Yep.
What then, big question, is the impact of this particulate matter on infant mortality?
In the study region, we found that 1 microgram per meter cubed, that's the typical metric used, so the mass of particulate matter in a volume, an increase of 1 microgram per meter cubed was associated with about a 2% increase in infant mortality.
That sounds quite high, Jen. Is it larger than these previous estimates we've been talking about?
Yeah, so that was interesting. One of the things we wanted to do was establish this relationship for Sub-Saharan Africa because there had not been large-scale studies. And we had actually done a previous study without using this external variation driven by dust emissions. And there we measured an effect that was about half as big. And that's due to that economic confounding. And in fact, that's what motivated the dust study. It is big. It's in line with other estimates from different regions around the world, but it is sizable. And it means that it's a larger source of mortality than things you might commonly associate with infant mortality in Sub-Saharan Africa, like malaria.
Jen, I'd like to look at those conclusions and sort of project them into the future. We have climate models giving us some fairly scary predictions about what might be happening to the climate in Africa at the moment. What's it telling us about the amount of dust, the amount of particles that there are going to be in the atmosphere in the future?
That's a great question. So a couple of different factors play into this. Let me first just say that in terms of climate, there are parts of Sub-Saharan Africa that are going to move outside of their historical experience, right? So the hottest places are really going to be hotter. And if that's associated with drying, you might expect more local dust emissions. In terms of dust emissions from really large sources like the Burney Depression, we're a little mixed. We don't yet know from climate models, but a larger contribution is probably going to be from industrial and transportation and electrical generation choices that get made by governments as these countries develop. They're developing very rapidly.
And if I live in Sub-Saharan Africa, what can I really do to limit my exposure to dust?
The thing about particulate matter pollution is that it's ubiquitous. There's really no way to hide. And while it is a public menace, the policy approach has almost been hands-off private mitigation of exposure. We see that in California with wildfires, right? Where I'm sitting, households are kind of left on their own to purchase air filters if they can. And there are public air quality warnings about not overexerting yourself or being outside during bad days, but that's really where we're at. So there are private mitigation measures that's obviously inequitable in terms of who has access to those. And otherwise, it's really about mitigation at the source. For non-dust pollution, right, sort of industrial, transportation, electrical generation, those are policy decisions that get made about what technologies to use. And citizens everywhere should be thinking about their health and advocating for the choices that would be best for their communities. That's one strategy. When it comes to dust, we actually see really interesting things happening because while we don't know what's necessarily going to happen with the Burney Depression, there are some other areas in the world where new dust sources are being exposed. So again, I'm in Southern California and we have the Salton Sea, which is drying up, similar to say like the Aral Sea in Asia. And you get these new beds of very fine beach or playa exposed, and those are new dust emission sources that really strongly affect communities nearby. Great Salt Lake is another story here. And so we do see communities actually taking on very costly dust suppression projects because the impacts are so high.
People are actually trying to stop these places giving up dust into the atmosphere.
Yeah, building little ridges, watering the surface, trying all sorts of things to suppress these emissions.
Watering the desert just sounds like, I mean, it just sounds like it will be so incredibly costly that it's just not practical at all. Is this the case?
There's two ways to think about it. One is the pure cost benefit analysis from a human welfare perspective. And this always gets a little bit icky because we don't like to put prices on people's lives.
Yeah.
The public health community does have these estimates. And the global idea is that we should be willing to pay a few $1 million, depends on sort of who makes the estimate, to avoid premature death, especially of children. And so that adds up very, very quickly, right? If you think about avoiding something like hundreds of thousands of deaths, like we talked about in this paper, that really quickly adds up to be a lot of money that you would be willing to spend if you were doing this calculus. I think the other thing that goes into it, though, is that governments, especially emerging economies, operate on a budget constraint. Every dollar spent on dust suppression is not spent on education or building up infrastructure. And so depending on which framework you're thinking in, really, whether you're moved by the budget constraint or by the real pure cost benefit analysis, you might say it's worth it or not.
Well, let's put it another way then. If you wanted to avoid excess child mortality, then this gives us a way, this putting a number on it gives us a way to compare different policies. How practical is it to suppress dust?
Well, in that framework, which is really what policymakers often operate under, right? A world where you should be willing to pay the amount of money that would mitigate the damage that you would otherwise get from the next emission. And in that regard, it becomes quite cost effective to even do something really far-fetched, like go build irrigation-like project to water the desert in a place like the Burney Depression. So this is why you see cities like Los Angeles watering the Owens riverbed, paying millions of dollars every year because the value of life is really high.
I think that research like this is going to take us into thinking the unthinkable about some policy options in the future because, well, we're already in unthinkable territory. So, Jen, thanks very much for talking about it today.
You're welcome. Thank you for having me.
If you want to read the paper, it is called Air Pollution and Infant Mortality, Evidence from Saharan Dust. And the authors are Sam Heft-Neal, Jennifer Burney, Eran Bendavid, Cara Moss and Marshall Burke. This has been a VoxDev Talk, and the best way to make sure you don't miss an episode is to subscribe wherever you get your podcasts. You will find us there. And our past episodes, as always, are at voxdev.org, where we have articles about the papers we feature.